So the question is saying that we have given an integer array that is nothing but nums, right? We have given an integer array nums, as you can see here in the problem statement example, and we have given an integer k, like this we have given, right? Now it is saying we have to split the array into some number of non-empty substring. Means we have to split this array into some number of non-empty substring, means those substring that should not be empty. Okay, further the question is saying the cost of a split is the sum of the importance value of each subarray in the split. Means the cost of the split means if you are going to split the array into subarrays, means we have to find that cost. So then the cost of the split is the sum of importance value of each subarray in the split. Means how many split you are doing, that all those we have to do sum, right? And there is some importance value that we'll talk later of each subarray. We have to calculate the sum and then we have to return. Now it is saying there is a trimmed version of subarray. There is a trim function, the trimmed subarray with the version of subarray where all the numbers which appears only once are removed. Means we will create a subarray. There is a trimmed array, a trimmed subarray, and that is a version of subarray. Means from it is coming from the subarray, or you can say we will optimize the subarray in a such a way it will become trimmed. Means all the number which appears only once, if there is it is used only once, we will trim that. For example, in this scenario it is saying if we trim this subarray, if this trim this array, let's suppose, means 1 2 are getting only one time, appearing only one time, so we will remove these two from the array, subarray, and then this is become trimmed version of your subarray. Okay, now the problem statement is saying that the importance value of subarray array is k plus its length. Means the given length k and plus the its length, right? Means current length is 2. After the trimmed version, what is the length? We'll do the sum and we'll return it. That we are talking about. Means all the numbers which appear only once are removed and we'll do the sum, right? That is called the cost, you can say. And for example, if subarray is this, let's suppose 1 2 3 3 4 4, right? Then we will trim like this 1 2 3 3 3 4 4, right? Means 2 is 1 2 3 3 3 coming 3 times, 4 coming 4 times, right? So if we'll do the trim, so 1 and 2 is coming one time, means it is become 3 3 4 4, 3 3 times, 4 2 times, right? The importance value of the subarray is k plus 5, right? It will do how many elements is there, those, and the k value, that value we will return, right? And we will return the minimum possible cost of a split of the number will return. And the subarray is continuous non-empty sequence of element within an array. So for example, so it was talking about what, let's suppose we have given 1 2 1 2 1 3 3. So this is an array we have given, right? And we want to what we want to do, we will create first we will split this num, this is the num, and we will split this into subarray. So if we will split this into two subarray, let's suppose, so what will become 1 2, okay, this will be 1 2, another will be what, from here it will start again, right? 1 2 1 3 3, right? Let's suppose 3 3, like this it will become, right? Like this 2 subarray will come. So the importance of 1 2, it will come from here is what, there is no repetition, right? Means it is coming only once time, means its value is 0 plus k is nothing but 2, means it become 2. If we'll talk about this one, so 1 is repeating one time and 3 is repeating 2 time, means we will discard only 2, means 2 and 2 4, let's suppose we'll say 2 and 2 4, right? So in this case 4 plus k means it becomes 6. Now we will do sum of these two and 6, right, and this will become 8, right. So this value we have to return, means after the split there is some value we'll get, right, and those value will do sum and finally we'll return this. I think you understood, right? Still let's understand what we are talking about. Okay, give me 1 second. What we are talking about. What am I not created? Okay. Okay, so let's suppose we have given a array any number. Let's suppose what is the problem statement is saying, right? So if we will go to understand the problem statement, right, it was saying like we have given an array nums, right? This is a nums. So nums can be like what? Let's suppose I'll take 3, 1, 2, 4, 3 and 4 like this, right? Let's suppose this is the number. So 1 and 2 is coming one time, right? And there is a k is given, right? Means we will discard this 2 and we'll consider 3, 4, 3, 4 as a trimmed version of subarray. Got it? So means our goal is to split the array, right? Our goal is to split the array and split this array, right? This array we will split into some number of non-empty subarray in such a way the total cost of the split is minimized, right? So first of all we will have how we are going to generate the subarray. So if you are not aware with the subarray is a continuous non-empty sequence of element in the array, right? For example, if we want to create a subarray of 1, 2 and 3, right? If this is an array and we want to create the subarray, means first we can create one array, this one, then we can create 1 and 2, then we can create what 2 and 3 like this, and then 1, 2, 3 itself, right? 1, 2 and 3, right? Means 1, 1, 2, 2, 3, 1, 2, 3. So this is means continuous, not a different one. Continuous value should be there. It should not be empty. Okay, you have to understand very carefully, right? Subarray and continuous subarray, what is the difference? Continuous means after 1 there should be 2, either 1 or if 1, 2. So that is why 1 or 1, 2. If you talk about 2, then 2 is fine, but we can take what we cannot take 2 directly, right? We can take 2 and 3, 1, 2, 3 like that we have to take, right? If we'll talk about the trim version of this one, so we have to trim like this. If this is only one time is coming in the array, we will discard that one. You got my point? So like this we will discard the element and will create the trim version of the subarray, right? Means trim version of subarray is we will remove all the elements that appears only once, right? Only once it is coming in the subarray, we will discard that one, and then it will become what 3, 4, 3, 4, because 1 and 2 appears only one times, and so they are removed, right? Now the topic was saying the importance value of a subarray. So how we are going to find the importance element, right? Let's suppose this is what 3, 3, 4, 3, 4, right? Means it is coming 2 times, right? It is coming 2 times, means we have to take k plus the length of the trim version. So what is the length is 4, right? So if let's suppose k is 2, it becomes 6, right? The value of k, so that is called importance. It is nothing but importance value, right? IV, importance value of substring. We have to calculate k plus the length of the trimmed version of the array. Now if you have already the importance, sorry, after the split, if after the split we have two subarray, we will create the trimmed version. After the trimmed version, we will create what? IV value, right? Now what we have to do, all the IVs we will plus, and that is called cost of a split. Means cost of a split is nothing but the sum of the importance value of all the subarray in the split. You got my point? So let's suppose, for example, if give me 1 second, let me remove this. Okay, let's suppose we have given some array, let's suppose we'll create like this 3 1. Okay, 3 1, then we'll create 2 4 and then 3 4. Okay, so how we are going to find the cost of a split? So if we have the sum, like sum of the importance value of all the subarray in the split, if the split is like this, if the split is 3 1 2 4 3 4, right? From here we can generate, na? From here we can generate, right? How we are generating? We will split actually, right? The nums, and after the split, if the split is like this, right? The total cost of the sum of the importance, how we are going to calculate? First we'll find the IV value, right? How we will find the IV value? So what is the IV value for this one? 3 and 1. The k, whatever the value is, k plus its length. So this is getting discarded because it is coming only one time. It is also getting discarded because it is coming 1 1. It is also getting discarded because it is coming 1 1, right? Means k plus k plus k, right? What is the length? We'll keep adding, right? So if value is 2, so 2 2 2, it will become what? 6, right? If k is 2, in that case, after the split it will become 6, right? But if you split in something different way, that is also fine for us, right? Means you have to calculate in such a way, you have to split in such a way, you will find the cost of a split as max as minimum you can take. But that is not saying we have to minimize the total cost of splitting the nums into subarray, right? Our main objective is we have to minimize the total cost of a split nums into subarray. So the split is the main thing is that your split is the split we have to do in such a way you will find the minimum, right? Minimum cost we will find, right? I think you understood, right? So if you'll talk about the how we are going to define, let's suppose how we are going to do the coding, right? So first of all we'll create a minimum cost, right? So this minimum cost will internally it will find the all the subarray, right? Then we'll find the minimum cost will find, right? We will compute the cost of each element. Let's suppose if we have sliding window, right? Through the sliding window we'll go through all the elements. We will slide we will create a window of the subarray and we'll compute one by one, right? Means our first purpose is to find the mean cost. How we will find the mean cost? We will find the IV, importance value, right? So purpose we will create a so this method, like this method, what it will do, it will calculate the minimum cost to split the array using the we'll create a dynamic programming DP, and then we can take some variables like we'll compute later, we'll see, and we'll create a let's suppose a 2D array, and all the cost will keep adding and we'll store the importance value of the subarray. Let's suppose I and j plus 1 will take, right? There we will keep adding, or n is the length of the input array. Okay, so we'll keep iterating that and we'll keep filling the element, right? So first of all we will pre-compute the cost of all the possible subarray using the compute method. We'll create a compute method, and or any DFS method you can create, and it will, you have to pre-compute the cost of all the possible subarray using the compute method, and then you have to iterate the different subarray length and from from n to 1. Why I'm talking about, see, we have to understand what approach we are going to do, right? And then we will do the coding. Okay, so if let's suppose if any DFS method or the compute method if we'll call, right, so we'll create the frequency and we'll create a distinct you can say set, and we'll keep adding the value. If we have already iterated that value, we will not go for again for that one. Let's suppose, means our purpose to calculate the pre-compute value, means the cost of the subarray of length, that is starting from, let's suppose, L length, right, from different indices. We'll create the frequency, means frequency will keep track of the occurrence of the numbers in the current sliding window, right? And then we'll create a set of numbers that are appearing only once in the subarray, right? And then step by step we will initialize the sliding window, and for the first array of length we'll increment the frequency of number and we'll keep updating the distinct set, and we'll remove the number from distinct. If the frequency becomes more than 1, means unique, then we'll keep removing and we'll keep updating that distinct, right? Further, we'll keep calculating the cost of the subarrays, and we'll keep trimming the value, and we'll get the IV value. Once the sliding window for the remaining subarray is done, right, we'll move the window one step to the right side, and then we will add the new numbers to the right side of the window, and we'll keep updating the frequency and distance. We'll remove the old number, and then similar to that we'll calculate the cost, and we'll do we'll store it in the cost. Let's suppose 1 plus length plus 1 we can say, and I, right? So we'll do that. So better let's understand from the coding part, and let's do it by our own. Okay, so from where we will start, let's suppose let me zoom little bit. Okay, so here first of all we were talking about that we will take one int n. We'll take int n, and this is nothing but our nums dot length, right? And we'll create one int to get nothing but our cost equal to new int n. Right, two things we have done. Now what we should do, we should start the length from the L to 1, right, backward, right? We have talked about we will start with the last length to 1, right? So we'll create a for loop, and let's suppose our length is, we'll start the length from n, and length is greater than equal to 1, right? And length minus we'll do like this, right? We'll keep decrementing. Now DFS compute method will take, so that we will keep iterating on this value, right? Because we'll provide the cost array, then nums array, then we'll find the length, and then k, right? Now once it is done, we will create the DP, and then we'll let's suppose first let's do it here itself. So we'll create a DP array, right? So this DP array, what it will do, will store all the compute value after the for the each value. Let's suppose, right, let's suppose I will create an array dot fill, and then on the DP because we have to find the minimum, right? Integer dot minimum we have to find, then we'll take maximum, right? We'll fill with the max value, and then dp at 0 will assign nothing but k. Okay, further what we will do, we'll take int let's suppose I equal to 1, and then from I will take n less than n and I plus plus. So why we are going to start from 1? Because dp at 0 we have taken already the k element, right? And one by one will go from the 0 we will go by one to the k, right? Or sorry, n will go by one to the n, and will store the value. Let's suppose what I'm talking about, dp at 0 is already done, right? We'll start with dp at I. dp at I is nothing but cost at 0, and this is I. So we'll get the cost from there, and we'll keep storing the value here. For dp for int j equal to 0, and j should be less than I and j plus plus, right? For each row we'll go for all the j will go to all the I till, right? So dp at I is nothing but math dot, there is a mean function, will pass dp at I comma dp at j plus cost at j plus 1 and I. So this is the function, sorry, this is the function we will one by one dp at I plus 1 and j plus 1 will find, and will keep storing the values, right? Which is the maximum, either dp at I or dp at j plus cost of j plus 1, right? If this value is less than, right, then we will store here, which is minimum, it will go to the dp at I. So though you will have the minimum all the times, right? Then your dp is completed. Finally what we will do, we will return dp at n minus 1, the last value you will have the data, right? Now what we have to do, we'll through the sliding window we'll call the dfs method that we have created here. So I'll write here private void, no return type should be there, and then here. So this is your sliding window method. This is your sliding window method, and this sliding window method will keep updating the length, right? So initially we'll take the frequency of frequency equal to new int, let's suppose I will take a random value, will create, and we'll create a set of distinct value. This is nothing but set. I will say distinct value, will keep updating this value, new hash set, right? We'll create a for loop. I will int I equal to 0, I should be less than length, not this length, we'll take this length, and I plus plus. Gotcha. Because we have taken already the length, means what is the length is here. See, this is the cost we have. What is the nums? This is your num. What is the length? Length is, this is your length. What is k? Int is k, right? We have already done. Let's go count. Okay, now what we will do, at the frequency at nums at I, there is an element, that element will increase. Now what we will do, if the frequency at nums at I is equal to 1, right, means it is coming only one times, let's suppose, then this is, we will add into the distinct and will add, so that we can find the duplicate element occurrence in the array. Now similarly, like this we'll create here, but in this case if it is greater than 1, if it is greater than 1, or if it is greater than 1, or if frequency is equal to 0, in this case distinct dot remove nums at I, we will remove from the array, and so it will become the trimmed version, right? Means this is only, we are doing only for the trimmed version. Trimmed version, right? Trimmed version, right? Now once your trim version is ready, what we should do, right? Once your trim version is ready, what we should do here, after this for loop, right, we will create a cost at 0 and the length len length minus 1, right? Length minus 1 equal to length minus distinct dot size, yes, and then plus k. So you are updating your cost, right? Once your cost is updated, what we should create, we'll create a for loop. We'll start from int I is equal to length, and I should be less than cost dot length and I plus plus, like this. Now we have to do enqueue from the right, right? How will do enqueue? Int L equal to I minus len, and then frequency at nums at I will do plus plus. समझ में आ रहा है ना आप लोगों को? Okay, then frequency at once you have increased the frequency here, now same thing you have to repeat again, right? We have increased the frequency here, right? Like that we will do it again. Give me 1 second. Okay, so what we will do here, so once your frequency is updated, as here, yeah, this line I was talking about. Okay, if the frequency is equal to 1, we will add it. If the frequency is greater than or equal to 1, greater than 1 and equal to 0, what we will do, we will remove from the, and we should also make one contains. Okay, yeah, we should make one contains here. here. If it is equal to 0, one more we have to make here. And do and distinct dot contains. First time we will add and then second time we'll check if it is contains, right? So if it is contains, we will remove. Got my point? Then we will remove. We will make the distinct dot remove this one. So this is called plus plus, right? Similarly, we'll do for minus minus. Means we will check the frequency and we'll do minus. But this is for L. Minus minus. If length is equal to 1, its frequency is equal to 1, we'll add this value L. Otherwise what we will do here also. Similarly we'll check another value if greater than 1 or equal to 0, right? Or it contains, if the value contains, in that case we will remove it. Finally, now we'll update our cost. How will update? Cost at L plus 1 and I is equal to length minus distinct dot size and plus k, and then we will return. This is wide, so we will return. Let me check. Length. Let me submit. Yeah, submitted. Means working fine, right? Means what we have to do? First of all, what we have done, let's suppose we have created a cost, right? Cost 2D array, and then we are one by one we are computing the value, and we are storing onto the compute element, right? What we are doing, we are computing the value and then we are storing one by one. Why we are doing this? Because this method calculates the minimum cost to split the array using dynamic programming, right? So our main focus of this function is to calculate the minimum cost to split the array using dynamic programming. And for the dynamic programming we need one dp array, and we'll keep finding the minimum of the split element, right? How we will find? We have dp at I, and then we have dp at j and cost at j plus 1 plus I, which is minimum that we will return here, right? But how we'll find the compute, right? So this DFS compute method will pre-compute the cost of all the possible subarray using this DFS compute method, and it will iterate for all the different subarray, that is length is from from n to the last one, right? Means we are coming from where? N to 1, right? And then we are calculating this, right? So in this way we will calculate the minimum cost, right? So this is here we are, guys. I have tried many times, guys. So this is very easy program, and I hope you like this video, and if you have any doubt in the video, please ping me in the comment box. Thank you for watching this video.
Thank you guys, thank you for watching this video, and if you really like this video, please subscribe this channel.